Hello, this is a review of integer operations. Both my 7th and my 8th graders could benefit from listening to this video. All right, let's begin with adding integers. All right, so the rules for adding integers is a song. It goes to row, row, row your boat. All of the students should know this. Same signs add and keep, different signs subtract. Keep the sign of the higher number, then you'll be exact. If you know that song and you understand that song, you'll have no problem adding integers. Let's apply the song. So, the song says, same signs add and keep. That is, if both of the numbers are positive, that would be the same sign. Or if both of the numbers were negative, that would be the same sign. So think of it as adding a bunch of pluses together, or adding a bunch of minuses together. You're going to just add those numbers and keep them either pluses or keep them minuses because they're all the same. Different signs would mean some things would cancel out, and we'll draw some pictures to see how that works. So on the first one, it's a different sign. So we'd go with different sign subtract. Keep the sign of the higher number, then you'll be exact. So what it's telling me to do is take 7 and 13 and subtract those numbers. Now, order doesn't really matter here because we're ignoring the signs. We just want to know how far apart are these two numbers. And that is going to be the number part of our answer. And then we have to decide, should it be a positive or a negative number? Well, here's why the song makes sense. The song makes sense because on the -7, we have 7 negatives. 1, 2, 3, 4, 5, 6, 7. And on the 13, we have 13 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I take my negative and positive and I pair them together, I'm kind of crossing them out there, they make 0. Remember how if you have a negative number and a positive number and they're the same, they cancel each other out. So every time I have a negative and a positive that are the same, I call it a 0 pair. Or we can look and we can say these are the same amount of negative and positives, and I'm crossing a pair out each time. So basically, I took 7 of these away, right? Because that's how many negatives there were. That is why it makes sense to take 7 away from the 13. Now, when I do that, I have 6 left. 1, 2, 3, 4, 5, 6. And those 6 are all pluses. It's a positive 6 is my answer. It makes sense with the picture, but let's look at the song again. So same signs add and keep. Different signs subtract. We did the different signs. Keep the sign of the higher number, then you'll be exact. Higher number here is not saying higher number as in positive or negative, because positive would always be the higher number, but it's saying which one has the most, right? So if we're looking at 7 negatives or 13 positives, the most is the positives. So it makes sense that when we cancel out the overlap, that we would end up with a positive number. Let's move on. The second one also has different signs, so we're going to follow those rules. Different signs subtract. Keep the sign of the higher number, then you'll be exact. So I'm going to think about this as having 14 pluses over here. And think about this as having 6 minuses over here. Now, I didn't actually draw them all out. I just want you to think about it. So if I think about that I have some positives and some negatives, I know that I'm going to have some that get crossed off. That helps me to know that my number is going to get smaller. So I'm going to start with the big number, 14. I'm going to subtract 6. I get 8. So same signs add and keep. Different signs subtract. I subtracted. Keep the sign of the higher number, then you'll be exact. 14 was higher than 6. 14 is positive. My answer will be positive 8. Let's do the next one. It's a same sign one. Same signs, add and keep. Different signs, subtract. Keep the sign of the higher number, then you'll be exact. So it's saying same signs, add and keep. What that's saying is if I have 22 negatives over here and I'm not drawing them all out and 18 negatives over here, nothing cancels out. So I'm going to take these 22 negatives and these 18 negatives and I'm going to put them together. I'm going to add them. So I have 22 and 18 added together. I have 40. Okay. Same signs, add, I did it, and keep. Keep them whatever sign they started as. Because when I put a bunch of negatives with a bunch of negatives, I'm going to get an answer of a bunch of negatives. So my answer will be negative 40. Okay, I have another one down here. Negative 24 plus 9. They're different signs. Different signs subtract. So I'm taking 24, subtracting 9. I get 15. Should it be positive or negative? That's right, it should be negative. Keep the sign of the higher number. This is the higher number, and it's negative. So I'm keeping it negative. The next one, same signs again. Same signs, add and keep. So I'm going to add 11 plus 7, and I get 18. So same signs, add, I did it, and keep. If these are negative and these are negative, I'm keeping it negative because what am I doing? I'm adding up a bunch of negative signs. Okay, and the last one, negative 2 plus 9. I've got negative 2. I've got positive 9. I'd cancel 2 of them out, and I end up with 7 positives. In other words, I subtracted different signs, subtract 9 minus 2. See how I take the bigger number to subtract from? I get 7. Keep the sign of the higher number, positive, positive 7. You can draw a picture for every single problem on the test. However, some problems are going to have a lot to their picture. You can still do that. It might be easier to think about what would that picture of the big numbers look like. And that might bring you some more success, or you might be able to go a little faster. Okay, so subtracting integers. The rule we're going to follow here is to change the subtraction to addition by add the opposite. There's another rule that you could follow, which is keep, change, change. I think that one kind of gets a little bit confusing because if you accidentally say it wrong, you'll do the problem wrong. So we're going to change the problem to an addition problem. And we're going to add the opposite of what's behind it. So let's go ahead and do that. Okay. So subtracting this integer, I see a minus sign here. I'm going to change it to a plus. When I do that, I have to change the sign after. Now I'm going to follow the addition rules. Same signs, add and keep. So I'm going to add them and keep them, negative. Okay, again, I'm going to add the opposite. The opposite of negative 9 is 9. I like to just make it a plus. A plus plus doesn't confuse me too much. So now I just have 2 positive numbers I'm adding together, and I get 26. Okay, the next one, add the opposite. So I changed it. I've got negative 5 plus positive 15. They're different signs. Subtract. Keep the sign of the higher number. That's positive. Done. Add the opposite. There's the same sign. So I'm going to go negative 20. Sorry, I should have said 23. Since they're both negative, and keep it negative. Add the opposite. So I've got different signs. I'm going to subtract them. Keep the sign of the higher number. It's negative 17. And add the opposite. They're now same sign. I'm going to add those together. Keep the sign. Moving right along. With multiplication and division, there's several ways you can remember these rules. We talked about a lot of them in class. You'll notice that if they have both negatives or both positives, so in other words, if these are the same, you're going to have a positive result. If they're different, you'll have a negative result. So one way that I told you guys I remember this is I say different is bad, because I remembered that Arby's commercial when I was a kid that said different is good, but I didn't like Arby's, so I changed it to different is bad. That was a way that I remember this. Now, maybe you remember it because I told you that story. Maybe you have a different story that you're using to remember it. If you can't remember it, it might help you to memorize this triangle. All you need to remember is to have one plus and two minuses. It doesn't actually matter where the pluses and the minuses are located. So if I have a multiplication problem like 2 times negative 3, okay, I see that I have a positive and a negative. The way that I use this triangle is I would cover up the things that exist in my problem. So I have a positive that exists and I have a negative. So I know my answer of 2 times 3 is 6, but I need to know, is it a positive 6 or a negative 6? So what I'm going to do is I'm going to cover up a positive for the 2, that was positive, and cover up a negative for the 3, that was negative. And I would just use my fingers to cover these up. And I see the one that's left over is negative. So my answer is a negative 6. For all of these, I could use that same triangle, or I could think to myself, different is bad. So bad to me is a negative thing. So I think different is bad. If the signs are different, then my answer will be negative. So for this, if you're using that, you'd say 6 times 4 is 24. And since the signs are different, it's a negative 24. 7 times 9, those signs are different. Different is bad. 7 times 9 is 63, and it would be negative because they're different signs. Negative 15 times negative 5 times negative 15. I meant to change this to an easier number, but 5, we can do this by distributing and say 5 times 10 is 50, and 5 times 5 is 25. If we put those parts together, my answer is 75. Now, is it positive or negative? Well, I've got a negative here and a negative here. Those are the same, and same is good. Think of my best friend. We're the same, and that's great. We're not really the same, but it's a way to remember it. So here, if I'm using this triangle for the negative, negative, I would cover up a negative, and see how I'm left with a positive. Let's use the triangle again. And notice I made all of these multiplication problems look different because I wanted you to see all the different ways we could write multiplication. So this is kind of the little kid way of writing it. You won't see that much anymore. This is very common. This one's very common. The dot is still common, but we're going to even step away from that as we move forward. This is less common, but it's probably more confusing to see it with the parentheses in front. Okay, so I'm going to use the triangle again on this one. I'm going to take 4 times 9, 36, cover, and I've got a positive answer. I'll use the triangle again. 2 times 8 is 16. Negative times negative is positive. And one more time with the triangle. 3 times 6 is 18. A positive. Oh, I should have done the negative first. A negative and a positive. I have a negative result. Division is the exact same way. So if I have different signs, I'm just going to divide. 6 divided by 3 is 2. Different signs. Different is negative. 16 divided by negative 4. Again, they're different signs. Divide. If they're different, it's negative. 20 divided by 5 is 4. The signs are the same. So the result is positive. Negative 28. Oh, notice this. All of these problems are division, even though they look very different. So notice this one kind of looks like a fraction. This one kind of looks like a fraction. fractions are actually just division problems. So we need to kind of think about division and fractions the same. All right, so negative 28 divided by negative 4. 28 divided by 4 is 7. A negative divided by a negative is a positive. 44 divided by 11 is 4. A negative divided by a negative is a positive. And negative 27 divided by negative 9 is 3. A negative divided by a negative is a positive. Here is a list of all the rules, something you might want to write down, just a visual example. Hopefully you have a way of remembering each one of these. The biggest trick to getting these correct is practice, practice, practice. There's tons of websites you can go to. iExcel's my favorite because they'll have some videos for you that might stick with you better. Happy studying. Have a good night.